The following session will demonstrate how the gradient shader can be used inside a render tree to achieve advanced effect. So the first phase of this presentation is pretty much to introduce and do an introduction of the shader, and by going over all the options the shader offers to the user. So the first thing we'll do here is actually go and put a constant shader and put a gradient shader right here. So the gradient shader, as it is right now, the one that we pick is the same shader as you can find under the render tree menu node texture gradient. This shader will actually place the gradient using the UV information, UV projection that was put on the object, and basically bind the gradient to the UVs. So you can actually select either what UVs you want the gradient to be revealed. The other flavor of the gradient shader actually is the mixer gradient shader, where it's a 8 color gradient mixer, because it's really a mixer, and this one that will not use any UVs. Instead it will use either what we call a scalar input or a coordinate input, which is a vector, and that could be extracting UVs externally or having some other information that you want to put into a vector, for example. So this one is for very advanced render tree. This one is more like to create, let's say, like transparency wipe and very simple gradient and wipes over the surface of the object. So we'll focus mainly on the gradient texture for now, because we'll use this one to introduce how this shader can be used. So the first tab is the RGBA gradient. So if you go here, for example, and we render this, and in fact I'm going to go over the top view right here, and we see the actual gradient being rendered. As you know here, it will actually take this UV information and extract the UVW information. In this case, it's not a 3D gradient, it's really a 2D gradient. So only the UV information from the UVW will be used to texture the surface of the object. So as you can see here, this value is pretty much 0. So we only use the probably the V value. So depending on if you go for vertical, horizontal, for example, it will use the different UV information to compute the actual gradient direction, for example. Let's go back to vertical here. I'll go under render region here under options, and we'll go under active effects and set the color clipping to raw. The reason why I'm doing this is simply to demonstrate how the alpha channel behaves with this shader, because it can actually create a very distinct alpha channel, gradient channel in this shader. So I would like to use that. By putting it to raw, it will not do any sort of clipping or anything like this. It will just output the pure color. So now I'm going to go under render tree and connect the gradient directly over surface, because I want the alpha channel to be revealed in the actual image right here. So let's open this the shader right here. Voila. Now the way the gradient works is we have the portion here is actually the gradient control. The process of adding and deleting markers is quite simple. So if you click in a region where there's no marker, it will simply pick the color at the click location and use that as a marker. If you want to delete it, you can actually select the marker and press delete, for example, or you can actually right click on the marker and say delete marker. The other controls that you have is any information about the position of the marker is actually all the numerical values are entered here. So if you really want to type a very precise value, you can say I want the marker to be at 0.5, and I want to have a given color for that gradient. Also, there's two types of interpolation. You can go either linear or either cubic. Obviously cubic produce a much better interpolation, and it is set by default. Unless you really want to have a linear interpolation, I would suggest you leave it to cubic. Now the other part of the marker is what we call midpoints. So we can actually compact the actual color, the interpolation, either one side or the other, in order to create very sharp transition, for example. These midpoints are really considered as being other markers, so it allows to actually control the way the interpolation is being done between two markers. All these parameters are actually animatable, so if you go on the marker here, you can actually set it to 0.5, and that will always be 0.5 means it's halfway between two markers. So if I extend it, for example, it will remain at 50%. If I go here, it's still at 0.5. So that's how the actual gradient works. So if you move it very close like this, and then you move it, then obviously the actual midpoint will keep its value. All these parameters, midpoint, marker position, marker colors, are animatable. So you can actually go and let's say, for example, we could go here and click on one of these presets, and these presets will automatically set the proper color for each marker and also the proper midpoints and position. So if I go to black and white, it will actually make the gradient use this preset value. Now I can actually start and place the actual markers in to create this wipe effect. The important thing is to delete a marker. Actually, it's quite simple, because you can actually type a minus value to position, and that equates to deleting the marker. It means that the UI won't display it. It means the shader will basically ignore a marker with negative value. So that's really important, that if you actually texture the position of a marker, that you are making sure that the actual shader that drives the position always remains between 0 and 1 in terms of output value. Now we can actually take this and start to animate this through time. In this case, I can use some of these presets. So I could say key all. Key all means that take all the information, position, color, and midpoints, and key the value for all the visible markers. So now it will create this, and then I can go here and actually, compact this, and then do this, and voila. And then I could say key all again. So if I translate this, it will slowly animate the gradient shaders as I scrub the timeline to get the actual gradient animation that I've just created. The other tools that this shader has is remove keys. So if you want to remove all animation from all the markers, then you can actually remove keys, and that will automatically run script commands that will remove the actual animation expression, any sort of animation source on the actual marker position, midpoints, and color. It is also possible to actually texture a marker. So let's say, for example, I reset it back to a standard like gradient, a grayscale gradient, and I can actually click on one of the marker, and once this marker has been selected, so it's highlighted in red here, this color picker here will represent the current active marker. Then we can actually go here and start to connect, let's say, fractal shaders. Well, in this case I've just connected a fabric shader. So if we go back here, the actual color will not represent the procedural shader, but rather kind of a gray, and you'll see that the icon here has been changing. It means that there's an actual connection that's been made onto this particular marker. So you can actually go here and say disconnect, for example, and it will go back to the color that was set onto the on the marker itself. The other type of parameters here is the other buttons here. I'm sorry. Let me connect a fractal shader here. Let's go back up here, and we'll click on this one. If I say remove shaders, what it's going to do actually, it's going to delete and disconnect all the shader being connected to markers. So if you click here, it will basically go back to the previous state, which is the marker color that was set before the connection was done. So if you say reset, it's going to actually bring back some sort of default values for all the actual markers. The markers, there's really a maximum of 8 markers in that shader, and it is possible actually to stack them up in order to have 16 markers, and I'll show you how to do this. So for now, let's go over the actual gradient type, invert, and clip. So the first one is the type of gradient. So we have vertical, we have horizontal, so it's a different kind of landscape. We have radial wave, so that is pretty useful to do some sort of explosion, things like that. We have radial, so it's more like on the different axis, but it's always around the center. We have diagonal, one side or the other, depending. Then what you could do is use this and do what we call invert direction. So you can actually flip the actual direction of the gradient such that you can orient it the way you want it. You can actually flip it by moving the marker's position by setting, say if it's 1, then put it to 0 and things like that. But sometimes it could be quite tedious, especially if you do have an animation on each markers. It is better to use the invert direction. And clip is basically designed so if I actually just slightly make these marker not finish at 0 and 1, it will actually clip to 0. And the reason why we do this is sometimes user wants to have a finite location where the gradient and doesn't want to have any extrapolation of the last color. So clip here will either allow you to clip to 0 or actually extend, hold the last color on either side of the gradient spectrum. Also, each of the marker has also what we call an alpha channel, so you can actually make a particular region, let's say transparent. So let's take this one in the middle and put it to 0. I'm going to go to alpha channel and let's go to RGB. So I can actually start to use this to drive the transparency of a particular item. So that could be, let's say, the color of an object into space, for example. So it's really you can actually use this alpha and set alpha values per markers. But sometimes it is possible that the user may just want to have a continuous 2 markers. So in this case, this is an alpha override. It means that all the alpha channel of all these markers are basically ignored. Only the RGB are being used, and the alpha gradient is an override. It's taking over it. So you can actually start to do these fancy fall off in gradients over the actual UV domain. So again, these parameters here are the same as this one. They are not separate for alpha and RGB. They are basically just the same parameter being exposed on both tabs to ease the actual workflow. So under alpha gradient, there's also a similar preset. In this, since it's kind of grayscale, there's either black and white or white and black. Again, invert would have been here one way to actually do this. The texture tab is actually how to what UVs to use and what are the bump mapping values to be used. And again, you can actually start to create some kind of repeats here and do what we call here patterns. So you can actually start to create these very fancy patterns using the gradient and do remapping. In this case, it's not suggested to do this remapping since the actual UVs, the UV domain is between 0 and 1. And I guess that summarized pretty well how the gradient shader works. And I invite you to watch the other session about gradient that shows a gradient in action on a production scene. Thank you.